thank you everyone for coming today. My name is Sarah Saunders. I'm a software engineer from Manchester, England, and I work for a company called Capgemini, which is a global IT consultancy. And originally I was a Java developer, but the nature of working at Capgemini means you get to work on lots of different projects. And I've tried to pick projects around Manchester, so I've had the opportunity to work on a number of different technologies and platforms, including some platform as a service type product architectures and implementations. And part of this talk is about my fight to make that interesting. So the agenda for today, the first thing I want to talk a little bit about is the culture of working in IT, the way that we work together and how that's different. Then I'll make the sensationalist claim that I've put on the title to get you all in here. And then I'll talk about how, in reality, a developer's skills are required on these kind of no-code projects. And then I've done a few of these sort of platform as a service, no-code implementations, and I've noticed some sort of reusable pieces. So I've called that my platform as a service runbook. So after I've talked about the rest, I'll go through the highlights of the PaaS runbook. So the story starts here. This is Château Les Fontaines. It's Capgemini's university on the outskirts of Paris. You see the beautiful chateau building where we have the restaurants and bars, and then there's a state-of-the-art campus building set in the grounds. And every year for a week, the suits and major players of Capgemini come to Les Fontaines to talk about the next year, the strategy for Capgemini in the year ahead. And last year, they also held a hackathon during the week, so I got to go along as part of the hackathon. So here we all are. They gave us these lovely, brightly colored T-shirts. And so while all the suits were wining and dining in the chateau, we were down in the campus 24/7, building some applications for our clients. But we didn't escape completely unscathed. We got called into the chateau at one point, and they sat us all down, and they said, "You are different." And we said, "Well, you're the one that gave us these T-shirts." But it turns out that wasn't what they meant. They were talking about the culture that we have in the development community and how we work together. They said that in other areas of Capgemini, you know, some of the business consulting areas, there isn't this culture of sharing. People have their documents and they'll hoard them on their personal laptops. They don't even share them, you know, within their divisions, let alone outside their divisions. And so they were looking at the way we work in software engineering, you know, the way we release open source code, we post comments to communities, and they were saying, why is it? Why is it that you do that? And we thought, well, that's a really interesting question. So took some time out from the hackathon to sit and debate it. And we thought, what is it about the culture of IT? Does it hark back to the hacker culture? You know, Levy's sort of definition says that, you know, hackers are promoting the sharing of data, that all computers should be for everyone. And there's a great definition. Hackers are anti-authoritarian and creative. Is it this hacker culture that makes us want to share? And then we thought, well, the structure of some of the applications that we use, things like Stack Exchange, encourages gamification. So, you know, is it because of that we share? And we thought, no, it's not necessarily because we're all wonderful, creative individuals. It's more the fact that we actually get valuable kudos from sharing. You know, if somebody was looking to recruit some IT staff, they would look at their open source contributions. They would look at Stack Exchange. Does this person ask questions? Do they answer questions? And the more that you share, the more kudos that you get. And that actually adds value to you as a developer. So unlike the other communities within Capgemini where they don't get any benefit from sharing, we are actually benefiting from sharing this. So the question is, why are we so open to sharing our code? You know, if you wrote a nice new sorting algorithm, you would probably post it. You probably wouldn't even write it, to be honest. You'd probably Google it and copy and paste someone else's. And that's fine. That's just part of the way that we work. No other division would do that. And why? So the more we thought about it, the more we thought, well, actually, the value of these little pieces of code is actually low in itself. that's not where our specific value is. The lines of code that we write don't really have any value at all. And so we started to scare ourselves into this idea. Hang on, coding as a concept, we all identify as coders, but we've just realized that it has no value. Is coding dead? So there's my sensationalist hypothesis for you. To elaborate a little bit on what I mean by that, I was thinking it's a little bit like the abstraction given by the Babel fish in Hitchhiker's Guide to the Galaxy. If you don't know the Babel fish, it's a concept that Douglas Adams uses to get over how these intergalactic species communicate. The idea is you put a fish in your ear, and the fish translates for you between all these alien languages. So you've abstracted above the actual level of language, just going straight to the concepts. And so I was thinking, have we got to that stage with coding where we've abstracted above it? Every little piece of code that you could ever want already exists. And it's actually using these building blocks and building at a higher level of abstraction that gives us the value that we have today. So a hypothesis for my claim is this product called Mendix. Has anyone heard of Mendix before? It's a platform as a service, and it allows rapid application development using just drag and drop, not writing any code. You just fill in forms and you drag and drop, and you produce an application with a presentation layer, a persistence layer, and some business logic in the middle. So the kind of thing that you would write for an enterprise as a product, over and over again. So I want to do a demo of how you can use Mendix to write an application, just to sort of give you an idea of what these low-code, no-code products look like today. So here we are. Actually, I had a slight problem with the demo in that I've got the Mendix app on a VirtualBox, but for some reason my VirtualBox doesn't like the network here. So what you would do with the platform as a service, of course, is you would start accessing it in the cloud. So Mendix is hosted in the cloud. So you would first log on to the home page, create yourself an account, and then you would just click Create App. And what that will do is it will set up a development space for you. So if I look at some that I've built already, you see the kind of things that it gives you. It's not just the code itself. It will give you a space where you can work in an agile way. So they have something called Team Server, which gives you a repository where you can check in and check out code and do versioning. They give you a link to something a bit like Jira, so you can manage your teams and the people who use it. Well, we'll let that side of it plug away, and I'll show you how you would actually create the application. So this is the IDE. It's called Mendix Modeler. And this is what I've done here is I've just created a blank new project. So the first thing that I might want to do is create my data model. So to create a data model, you can just drag and drop your entities. So this is an example from the Mendix website of just creating a simple employee website to manage your employees in the company. So you might have an employee table, and then you can add attributes, so that have a name, email, phone number, what else, an address, county, and then they might have date of birth, which would be a date. So you can see that there's some representations of different types. Slightly off the screen now. And then you can do things like you can create an enumeration. So if I wanted to represent the different levels that you can have in your company, I could create an enumeration called level, and I can add junior, associate, senior. And then I might want a table to represent departments. Department might have a name, description, call that department. And then if you want to link the tables, it's simple. You just drag and drop to create the connection between the two. So easy to do. And then the next thing I might want to do is create a home page where I can display this data. So to create a page, you choose a template. So this master detail will have a list of all the items at the top, and then when you select one, it will show you the details. You can choose different navigation layouts as well. And then, unfortunately, this isn't fitting the page too well. Oh. How do I get this to display better on my screen? Does anyone know? Because I can't see my menu bar. The piece that I want is just out of the screen, that side. But basically, if I could see the thing, then you can drag and drop from your domain model onto this central piece to populate the grid, and then you can drag and drop the pieces in. Well, okay, let's move on to trying to do the interesting bit, which is the data layer in the middle. So I can add an action button, and I might want to call it promote. And then I can create, I can say what happens when I call that action. I can say I want it to call this Mendix concept called a microflow. And I'm going to call that promote employee. Okay. And then if I say go to the microflow, then you can see, again, I'm going to struggle here because the building blocks are on the other side of my screen. But so here I can say I want an exclusive split. So I want to split based on the input. And it's going to be the level. So because when you want to promote an employee, you want to change their level. So I want to say, look at the, oh, where's my employee? Oh, that's because I can't drag the table onto the page. It doesn't know that I'm talking about the employee. Oh, this is so annoying. Even no-code demos can go horribly wrong. Is there a way that I can change the resolution of my screen so that I can actually see the whole screen? Is it I don't know. Because it's in a virtual box, which is running on here. So, oh, maybe if I exit the full screen of that. Yeah, that might work. Yeah, woohoo. Okay. So now I can show you how you simply connect a grid to a data model. So I want my employee here. And then you can add the relevant fields just using drag and drop to map your data. So now my promote button should know that it's an employee. So when I edit the microflow, it should be able to, oh, I might have to recreate it. Delete that. Okay, so, So, there's my flow. I want my exclusive split. And this. So finally, I got my level. Oh, I never put it in my data model, I don't think. I didn't. So first thing to do is add that enumeration to my data model. So then, when I'm in my promote mode, I can split based on level. So there are 3 options for a level. You can be a junior, senior, or an associate. So we'll add those in. Or you could not have the value set at all. So we'll add that one as well. And then I can say, what would I want to do under the situation that an employee is a junior and I'm going to promote them? I'd want to change that object. So we'll drag in a change. So you would say change the level. And it would go to associate. And similarly, if you were going to promote an associate, then what you would want to do is change their level to be a senior. If they're a senior already, then we don't need to change their level, so we can just show a message saying already at the highest level. So I just need to add in my exclusive split which is which. So that's junior, that's associate, and that's senior. Okay, so if you're not a developer, you might find that marginally interesting. You developers are probably dying of boredom, but you can imagine quite a lot of the applications that you build could very easily be developed like this just by dragging and dropping. And then what Mendix is offering you is the cloud solution to then host that. So when it's up and running, this is one that I made earlier, you can see that I've got my employees. Am I actually? Yeah, I'm on the internet. So we'll leave that running, and it may well show the page. But in the meantime, I could probably, if we look at the source of what we've actually built here, you can see it's not just like a flash or an image. It's got proper technology in it. It's got Bootstrap. It's got Dojo. It's, you know, Lee from marketing could build this. And what he's effectively built is a Scala application with a Bootstrap front end that's hosted in the cloud. So what you might be thinking is, isn't this the same old buy versus build argument? Yes, it is, but I think it is worth constantly reconsidering this because the factors around it change. The potential cost of buying versus building is coming down because when it's hosted in the cloud, there are different models. For instance, there's, you know, you can pay per CPU, pay per user, pay per data, so you're not buying one big product. You can cost it in different ways, which makes it more affordable for different companies. Another of the arguments that was on the buy versus build scale is, oh, well, you've now got this dependence on, say, Mendix as a company. But if we're hosting in the cloud, you know, if we're already using infrastructure as a service, we've already got that dependency. So, you know, why not just increase the scope of where that dependency lies? And I think also we've got a better idea of an enterprise application lifespan. So when I say enterprise application, I mean, you know, you couldn't write Mendix in Mendix. You couldn't write, you know, a new language in Mendix. There's obviously a limit to what you can use this for. But I think a lot of what I would say enterprise applications, things that we at Capgemini build for companies to support their business processes, that you could use Mendix for, we get a better idea of how long their lifespan is. And it's not 10, 15 years. It's 5, 6, 7, 8 years. So your dependency on Mendix existing is only 5, 6, 7, 8 years. It's not decades. The ability to customize is getting better as these applications get better. As I mentioned, Mendix is actually written in Scala, so it runs on the JVM. So if you wanted to go down to the level of customizing for the sort of, you know, 80-20 rule, the 20% of your client's requirements that don't fit into the Mendix model, you can actually write custom Java classes, and they will run because it's on the JVM. So yes, it's the same argument, but worth reconsidering. So when you show Mendix, as long as your demo doesn't go too wrong, to project managers, they get really excited. They go, even a baby could do that. And then they look at the developers and they go, why do we have these really expensive guys when we'll just get Lee from marketing to do it? And there's those words that send a chill down the spine of any developer. All these years of creating a robust engineering discipline. Why do you need that? We've got Lee from marketing now. So we all know that these kind of projects require software engineering knowledge. But do we ever stop to think about that as our value? I went to the Mendix tour, which is, Mendix went around Europe to different cities and held meetups where everybody got together and talked about their success stories. And there were a lot of success stories where, be a small firm with a small IT division. They had 2 people, and the CTO built the proof of concept himself, and it all went swimmingly. But then after that stage, after the proof of concept layer, people were saying things like this. Who were going, oh, I wish I could just lock that down so people would stop fiddling with it, or people don't understand how to use this properly. All the things that we, as developers, learned years ago, these people who are coming in thinking you don't need development skills have got all those hurdles to overcome. And so, yeah, I think, in conclusion, don't worry, our skills are obviously still necessary. We know that our jobs aren't at risk. We know we'll be around for years, but we probably need to kind of emphasize that we are software engineers. My official title at Capgemini is a senior developer, but I think of myself as more of an engineer because of the range of projects that I work on. My skills is not the fact that I can write an array copy in 16 characters. It's the fact that I can then robustly deploy that array copy, between environments. And so in the next section of this talk, I want to talk through a couple of projects that I've worked on, which have been platform as a service, low code. There hasn't been any development, but we've still wanted to robustly package them as development projects. We still wanted to work in an agile way. We want to plan, design, automate, repeat these. So the basic goal of taking a deployment unit and moving it between environments is the same, even if you're working with a no-code product. So the first case study I want to look at is a tool called API Connect. It's an IBM product. They used to call it API management because that's what it does. It sits between a company's internal APIs and their clients, so they can do things like create subscription packages, they can use throttling, they can get people to pay different amounts for different uses of their internal APIs, and they can make all their APIs look standard. So it's sort of a pipe, a proxy between the 2 layers, and the tool allows you to configure these interfaces. So when we were working on the project, there were a few interesting issues that we came up with, and a few sort of hurdles that we had to overcome. So I'm just going to sort of talk through those. So we still wanted to implement it in the same way. And the first issue that we sort of hit up against is the concept of a cloud environment. They went out and they bought from IBM these 5 environments, which they named after their 5 environments that they had internally. And then they started just playing around with the development environment, putting a load of data on it and granting, low-level access. And it's like, why are you granting access to this? This is internet exposed. Everybody can see this. And they're sort of saying, oh, it's only the development environment. And getting that concept across to the client and to the development teams and the test teams of, okay, just because we've called this virtual machine development doesn't mean it's any different from the virtual machine that we've called production. And in fact, you need to think more about security at the development side because you want less people to access it, probably, than you do in production. So that was our first change of definition that we came across. And then when it came to the deployment to these environments, we came across another big hurdle of what actually is our deployment unit? Because if you think about writing code, you might get it compiled to, some form of jar or war or whatever, and then you would move that compiled unit between environments, and the thing that would change would be the configuration, so that your dev1 points to the dev database and the sit1 points to the sit database. But all we have here is that configuration piece. So if that's what you're changing as you move between environments, then what's the purpose of having these different environments? Are you testing, all that you're deploying has changed, so there's no real point in moving it between the environments. So I was thinking about it, how should you use cloud environments to line them up with internal ones? So the conclusion that I came to is the concept of a cloud development environment is flawed. I mean, call it a sandbox if you like, and go and play in it and learn about the tool, but don't connect it to any of your internal systems. It should be connected to mock endpoints, inputs and outputs. And then sit, I can see a valid case for connecting up a sit interface, because you need to do things like performance testing, load testing, how is this system going to perform? So I can see the value in having a sit interface connecting to an internal sit interface. And then when it comes to UAT, your UAT environment should probably contain the production configuration. So you want to get your users to confirm that the data they're looking at is the production data. Then you take that configuration unaltered and you move it to pre-prod so that you're practicing the concept of moving the configuration. And then when you're happy with that process, you can then move it to production. So, from my opinion, UAT, pre-prod, and prod cloud API management interfaces should probably all point to production. And the client had a complete collapse about that and saying, oh, you can't have, non-production things pointing to production. So we ended up doing it this way. But I really do think that we're not really proving anything by changing the configuration between these environments. So that was a big hurdle. And then the third one was testing. What we've effectively built is a pipe. So we don't want to be testing the underlying system, and we don't want to be testing the calling system. So all we want to test is the middle bit, which isn't very much at all. I mean, API management can do things like translate between a SOAP API and expose a REST API, or it can, stick two APIs together to create a third, in which case you have got a bit of logic in that you need to test, to unit test, and then to pass through your validation process. But a lot of the time, if you're just mapping endpoints, you don't want to test the underlying endpoint. So we came up with the concepts of, okay, a successful test, we don't care what the data in is, and we don't care what the response is. We just want to know that we've sent it in and that we've got a response. We had tests around valid credentials. Can people with no credentials not get in? Can the right credentials reach the right data and just the right data? So we built tests in that area. But we tried not ever to look within the actual package we were posting unless we had done some manipulation on it. So then I moved on to another project with a product called Cast Iron, which again is an IBM WebSphere product. Cast Iron purchased it, but they don't seem to really have a strategy for its use, which is a shame, because it really was an excellent product. I've got a picture of Marvin here because the robot from Hitchhiker's Guide to the Galaxy, brain the size of a planet, and you ask him to open doors. That's really what we were doing with Cast Iron. We were using it as an API gateway, but we could have done so much more with it. It's hardware-backed, and that phrase always really impresses me. Again, it was designed to transform and expose APIs. And what we were using it for in this project was to act as a proxy layer between internal company APIs and the external cloud products that they had purchased. So they were using Salesforce, they were using a cloud-based identity management system, and they wanted all the cloud API calls to come through Cast Iron so that they could use that as a sort of proxy level for mapping their content. So I've just got a few screenshots of what it looks like to develop in Cast Iron. Again, they have an IDE. It's sort of drag and drop. You can see that you create a kind of flow. So there, you set up an input, and they have a number of forms-based connections to common inputs. So if you want to connect to Salesforce, it will give you a form, and you just fill in the fields that you want. And under the covers, it will create the right kinds of sort of OAuth connections for you and set up database connections, things like that. And then you can see you have a sort of workflow, so you can add in manipulation pieces to change the data. You can connect to different sources and combine them. And then it was a little bit more complex. You can have variables, so you can have state, you can have activities, so you can have functions, and you can even go down and create your own functions. You could have custom JavaScript. So it is a little bit more than API management. There is some code going on there if you really needed to use it. And again, we started to come across the same sort of queries. The first issue that we had was with security. We were using a cloud-hosted version of cast iron, which was a bit of a waste, really. And the way that it was used, we would connect to it via HTTPS, and then inside it would have a basic username and password. But the SSL termination would happen at the cloud layer, and then inside you would be expected to connect to your box. And our client said, oh, it's okay, because we'll use IP whitelisting. I was thinking, IP whitelisting to a cloud, only everyone in this cloud can come in. And in fact, all you have to do to create a virtual machine in cast iron is just log onto the website and create a free 30-day trial. So it's not actually very secure, and we had to spend quite a lot of time explaining, the architecture of this to the security guys with the client, because they just weren't used to working with cloud security. And then the second issue that we had was a kind of limitation of the product. The version control strategy that came with cast iron meant that every time you opened one of these flows, it would create a new version, and we just had a proliferation of versions. So we had to create our own strategy, which was around the naming convention that we used for the XML configuration of these workflows. So it wasn't ideal. We ended up duplicating the version control. We ended up having to create our own subversion repository to manage the XML files. And again, it was a limitation of the product, which is not something that you obviously come across if you're building your own. And then again, we hit this issue of how to test. We wanted unit tests, so we wanted mock endpoints, but we're not in the happy world of Java where you've got JUnit and Mockito and all the libraries in the world to back you up. So we ended up writing our own Python scripts, and we ended up deploying things to Amazon that would act as an internet-based empty mock endpoint. Because, of course, you can't just spin something up on localhost when everything's in the cloud, because it won't be able to see it. So, yeah, a new world in the space of testing. So the conclusions that I drew from working on these projects was, yes, we can approach it in the same way that we approach development projects, and we should, and we need to keep the same principles in mind. We still want to be unit testing. We still want to be automating everything. And there was some reuse in the projects that I've seen. There were some sort of similarities that I could draw. So here's my PAS project runbook. So I just sort of roughly broken it out into areas. So if you're working in an agile way, there's a sort of design stage, there's a testing and building stage, there's a proving stage, documentation, and then you want this all automated. You want a continuous integration pipeline. So how does that work in the platform as a service world? Well, the design and planning stage, you need a different focus. You need to be looking at the limitations of the product that you've chosen, and you need to focus on security, because there are going to be limitations on how you can secure things, and you need to check with your client straight away whether or not it complies with what they want, because if it doesn't, with a PAS product, you're stuck. So the testing and build phase should obviously be much, much smaller, and in fact, in reality, we found that it was. We did get a lot of quick wins out of this. When I was working with cast iron, there was a separate development team building the front end, and they were spinning out little microservices that could talk to their RESTful pages. And they were hosting them all on Amazon. And so they were very carefully setting up a complex array of virtual machines with little microservices running on them. And they were running very behind with the project. And we said, actually, cast iron could do that. Now you've bought the license. Why don't you use it? Why don't you, do all of these small data manipulation microservices in cast iron? And we built, 7 or 8 in a week, whereas they'd been planning that over several weeks. So, once you get to that stage, there are wins in the build area. But then the testing area becomes much harder. How do I have a scriptable unit test when I've built a platform as a service module? So we had to do quite a lot of work in that space. We were writing Python scripts and using online tools that I'll talk about later, some sort of handy online tools for testing PaaS products. Oh, I mean that one. So, and the proving stage, as I've already mentioned, you have to think about what you're actually testing. A lot of these integration pieces were just pipes, and we didn't want to be testing the underlying system, so we had to really think of what's the use case of the actual product here, and how can we test that. And in the automation space, some platform as a service products will provide an API or a command line interface that allow you to deploy and change variables of your configuration. But it's a limitation of the product. Again, if they're not offered, then you probably won't be able to script the build. You know, if you're expected to log onto a website and press a button, it becomes much harder to script a build for your system. And then there's the security as well. API Connect comes with a command line interface, but it doesn't have certificate-based security, so you basically have to type in your password. So I think Jenkins will offer a way to at least obfuscate passwords so that they're not sitting there in clear text, but they're not encrypted. And so there were security issues around whether or not we could create the build pipelines that we wanted. At least the documentation bit is much easier. Most platforms as a service, obviously, if you have built something that automates the writing of the code, it's fairly easy to automate the documentation of it as well. So Mendix, Cast Iron, API Connect all offer really easy ways to generate documentation. Whether anyone ever reads it or not is another matter, but it's quite handy in the API space to be able to use Swagger. With API Connect, you can just write your Swagger definition, and then you can load it in, and it will generate the connections for you to make that API. And then the continuous integration space, I've already talked about having the APIs and the command line interfaces that you really need to get your pipeline, and it all depends on product limitations. And again, how do I monitor it? A lot of these platform as a service offerings do actually provide monitoring, but if they don't, then you need to build it yourself. And we had to do that with Cast Iron because their monitoring piece was very poorly linked with the actual system. So if the system was completely down, the monitoring piece wasn't getting any negative responses for it, so it was just saying everything's fine. So we eventually realized this, and we had to build our own little flow that pinged Cast Iron from an internal system going, are you there? Are you there? Are you there? So we could do it, fortunately, but we had to build it ourselves. And then the support side is the most frustrating for a developer. If you're used to being able to just log onto a box, attach something that can look at memory, put breakpoints in, when you move to working with a platform as a service type product, it's like Homer Simpson when he's trying to manipulate his piece of radioactive material, and he has to put his hands into those big rubber gloves and grope with it. You feel completely tied. You can sort of say, I think this is going on, and if only I could see these logs, then I could probably confirm it or not. But all you can do is open a support ticket with the company that owns the product and just wait. So there was a lot of trying to be zen while we waited for support tickets. And I spent some of the time I was waiting for support tickets thinking about what would a support ticket graph look like over time when you implement a platform as a service product. So I can imagine when you just get the product and you've no idea how to use it, you might read the manual, you might not read the manual. And so you're just opening ticket after ticket going, well, this doesn't work, it doesn't work. And they're all closed quite quickly because most of them are user error. And then when you start building in anger, you start doing things like performance testing, then you start pushing the limitations of the product, and you get a smaller subset of tickets open which are more serious and actually require the PaaS vendor to make some changes, and then you get a much slower rate of closing the tickets. So not that useful a graph, but it kept me busy while I was waiting for my tickets. And then the final piece is the kind of tools that we use when we were working on these projects. So SOAP UI and Postman, I'm sure you've come across, invaluable in scripting tests. A lot of them we could just put a load of calls together and validate the outcomes and run that as a script. And then these products, HTTP bin and request bin, you could use as mock endpoints. So you could configure your Cast Iron API to talk to this mock endpoint. And so when you send in your request, what HTTP bin does, it will just print out what the request was, so you can see what you've actually sent, which was an invaluable tool when we were building these sort of pipelines. And then we did a lot of manipulation of data, XML to JSON, XSL parsing, and we used this product called XML Spy, which I don't know if you've heard of, but it did everything that we needed, and we ended up purchasing a license for it because it really was incredibly useful for working with API management and cast iron. And then Python was a language of choice for writing our own automated tests. I think it was just because we had a lot of people with that skill and we could get it running on any kind of tester's box quite quickly. And so we had quite a lot of Python scripts holding our API calls together so that we could create a sort of Jenkins-esque pipeline. So here's my conclusion, just to say that, yes, we are all developers, but it's not necessarily the actual writing of the code that gives us our value. It's our software engineering expertise. It's our seeing this as an industrial process that we can do in a repeatable and manageable way. It's our understanding of security and how we can work together. And as the slide says, the devil is no longer in the details. So thank you very much for listening. I don't know, hopefully we've got a bit of time if anyone had any questions. Good. Well, thank you again.